The binomial problems basic. So we are looking at binomial distribution. So the binomial problems usually give you three numbers that are your main focus. So let's read this. A TV executive is interested in the popularity of a particular cable TV show. She's been told that a whopping 68% of American households would be interested in tuning into a new network version of the show. If this is correct, what is the probability that all 6 of the households in her city being monitored by the TV industry would tune to the new show? Assume that 6 households constitute a random sample. 3 numbers that we deal with in a binomial distribution are P, N, and X. P is the probability of success. N is the total number of trials. And X is the number of successes. Okay, so a binomial distribution, just a little background before we start, is a experiment that has to fit these certain criteria. So 2 of the main criteria that you have to fit is you have to have a clear success and failure. Okay, so this clear success or failure of this one is you would be interested in the show or you would not be interested in the show. There's no other option. Okay, so we're counting if they are interested, it's a success. If they're not interested, it's a failure. So you have a clear success and a clear failure. So that's one thing that has to happen. You have to have a set number of trials also. Okay, so we have a set number here. We are looking at 6 people and that's it. So there are some more that have to be independent, but those are the 2 main ones that we are going to look at. So our probability here is given to us. It is 0.68 or 68%. The number of trials that we're looking at here is 6. And the total number of successes. So what does it say? It says we want the probability that all 6. So that keyword there, I'm going to write it, is all 6. So they will change that because they could say less than or greater than or anything like that. But this problem says all 6. So the formula, we could use a formula to do this, but Alex has a handy calculator for us. So let's jump over to the calculator. The calculator has this binomial button down here at the bottom, and it is separated out into 3 things. So the first blank is going to be your N. So there are 6, okay? There are 6 total households we're looking at. The second blank is going to be the probability, so 0.68. So this last blank is where we're going to put our X. Now this is a little bit different because we want all 6. So we know all probabilities between 0 and 1. 1 would be everything. So since this says less than or equal to, it's actually called a cumulative probability, and it's adding up the probability that we get 0 people, the probability we get 1 person, well, probability we get 2 people, probability we get 3, 4, 5, and 6. So it's adding up all of those. So what I actually want to do, I just want the probability that it's 6. So what we're going to do is put a 5 in here. We're going to put a 5 in here, and that's the probability that we get 5 people, or 4 people, or 3 people, or 2 people, or 1 people, or 0 people. So that's going to be a high number. So it's 0.901. But I want the probability that we're going to get 6. So I'm going to store this, and I'm going to do 1 minus that stored number, press recall, and this is going to be the number that we get, that the probability that we get all 6. 0.098867. So at least 3, that's enough. And that is our answer. So just to explain this one other way real quick, go back here. If you look at a chart, you have 0 people, 1 people, 2 people, 3 people, 4 people, 5 people, 6 people. So in a probability distribution, you have all these different probabilities. So we got 0.901 for 5 or less. So this is adding up every probability all the way back, okay, from the beginning. So I know by the rule of probability distributions that these have to add up to be 1. All the probabilities have to add up to be 1. So to figure out what this is, that is why we did 1 minus 0.901. That is how we got an answer of 0.0989.